In the previous chapter, we have learned that de Broglie hypothesized saying that electrons behave like both waves and particles, correct? Remember the matter wave theory and everything. Now, here, see this Bohr's postulate, whatever was there. Uh, Here we assume that electron is a particle, correct? It has a specific orbit, it has a specific velocity, it has everything is defined. But then de Broglie proved that electron is both particle and a wave. So, how are we going to use this de Broglie's theory or hypothesis in proving the Bohr's postulate? For that, again we look into Bohr's second postulate. MVR is equal to NH by 2 pi. Okay, now look at this particular figure. Guys, now I'm sure you must have seen this figure here. Let's try to understand what this particular picture represents. Now, an electron is moving in a circular orbit, correct? That was one of the Bohr's postulate. If an electron is moving in a circular orbit, then electron also behaves like a wave. That means an electron should have a wavelength in that particular orbit, correct? This is the meaning of that particular figure. So what you're seeing more like a stretched rubber band, correct? Like imagine like this. You stretch a rubber band and you're going to pull the rubber band. You will see that vibration, isn't it? It's pretty much like that one. And what does that indicate? It's a wave, correct? An electron moving in a circular orbit has a wavelength, isn't it? Now, what exactly is this? What it states is a stationary orbit is that particular orbit where the wavelength, the de Broglie wavelength, that should be an integral multiple of whatever the circumference we have. A stationary orbit is that which contains an integral multiple of de Broglie wavelengths. Okay, this is the basic meaning of the figure. Very easy to understand now. Correct? Let's do the math part. Let's assume that the radius is Rn. Then circumference becomes 2 pi r, isn't it? Now, for permissible orbit, that means if the orbit has to be there, if the orbit has to exist, then what do we have? 2 pi Rn is equal to n lambda, correct? Number of integral multiples of the wavelengths. And we have lambda is equal to h divided by m into v, correct? In this case, it's going to be Vn. This is de Broglie hypothesis, isn't it? Now what we are going to do, we are going to take the same case. That is 2 pi Rn is equal to n into h by 2 pi Rn is equal to nh divided by m into Vn. Okay, now let's cross multiply. You'll get nvrn is equal to nh divided by 2 pi. Correct? Now, when I say MVRN, MVNRN, look at the LHS. Isn't this the Bohr's second postulate? NVR is equal to NH by 2 pi. So, using de Broglie's hypothesis, we prove that Bohr's second postulate is correct. Now, what inference can you get from this? The inference and observation is very simple. That is, an electron in the stationary orbit of the Bohr's model also behaves like a wave, in the sense that wave particle duality exists in an atom even though the electrons are in the stationary orbit. Okay, this is the proof, this is the inference. Okay, so de Broglie's hypothesis, this proved that stationary orbits exist within the atom, which is basically the Bohr's second postulate. Okay, this is the explanation whatever de Broglie gave for the Bohr's theory.